Why is the universe silent? Maybe it's not. Maybe we're just too far away and the signals are too faint to hear. Welcome to the Signal Degradation Hypothesis. The Fermi Paradox asks a simple yet haunting question. Why haven't we detected intelligent life, despite the overwhelming odds that it should exist? For decades, scientists have wrestled with this question. So what is it? Are we alone? Are we too early? Or maybe too late? Most theories struggle to reconcile the paradox with the sheer vastness of the universe. But what if the answer lies not in what we look for, but in how we listen? Imagine this. You're in a massive city with a population of over 1 million. Yet as you commute, shop, or stroll through the streets, you meet no one. This is the Fermi Paradox in a nutshell. In the vastness of our galaxy, given the number of stars and potentially habitable planets, we should have already heard something. Anything. Even if the odds of intelligent life arising are just 1 in a trillion, the universe has over 100 billion galaxies, each with billions of stars and countless planets. Statistically, that still leaves room for trillions of intelligent civilizations. So why haven't we heard from even one? That's the heart of the Fermi Paradox, and why the silence is so unsettling. Oh, but wait, we have heard something. In 1977, a powerful narrowband radio burst known as the WOW signal was detected. It lasted just 72 seconds, and then vanished. No repeat, no origin confirmed. It remains the most tantalizing hint we've ever received, but its rarity might have a reason. Perhaps the signal was distorted, deflected, or weakened by the vast cosmic medium it traveled through. But here's the strange part. It came from the direction of the Sagittarius constellation, right where the supermassive black hole at the center of our galaxy lies. What if the signals from alien civilizations aren't missing, but simply damaged beyond recognition before they ever reach us? As a signal travels across light years of space, it doesn't move through a perfect vacuum. It weaves its way past massive cosmic objects, black holes, quasars, neutron stars, and dense molecular clouds. These giants bend space itself. According to general relativity, gravity can warp the path of light and radio waves. The stronger the gravitational field, the more a signal is bent, delayed, or even scattered. Some of that energy may be absorbed, some redirected, and much of it stretched into longer, weaker wavelengths through a process called redshift. By the time it gets here, a once clear message could be reduced to a faint, distorted whisper. We may already be surrounded by signals, but they no longer resemble anything we'd recognize as intelligent. Space isn't silent, it's full of background noise. The universe is constantly humming with electromagnetic radiation from stars, pulsars, quasars, even the cosmic microwave background left over from the Big Bang. This sea of signals creates what scientists call cosmic noise. Now imagine trying to detect a faint radio transmission from a distant civilization in the middle of all that static. Electromagnetic waves spread out as they travel, weakening over distance. They can reflect off dust, scatter around dense gas clouds, or get absorbed entirely. Some frequencies are drowned out by solar activity or galactic interference. Others redshift so much they fall below our detection range. So even if someone's broadcasting, their signal might be buried in the universal static, lost in the noise of the cosmos. Especially near the galactic core, the crowded heart of the Milky Way, space is chaotic, stellar density is extreme, and black hole activity is intense. Signals traveling through that region could be scattered, deflected, or completely absorbed by powerful gravitational fields. It's possible we exist inside a kind of silent zone, shielded by distortions in space-time we don't yet fully understand. But it's not just distant phenomena. Closer to home, the space surrounding our solar system isn't empty either. The Kuiper Belt, a vast field of icy debris beyond Neptune, may play a role in signal interference. Cosmic dust, charged particles, and even undiscovered black holes nearby could subtly degrade or disrupt incoming signals, long before they ever reach our detectors. We may be more isolated and more surrounded than we ever imagined. According to Einstein's theory of general relativity, mass doesn't just sit in space, it bends it. Massive objects like stars, black holes, and even entire galaxies distort the very fabric of space-time around them. And as light or radio waves pass through these warped regions, their paths curve as well. This phenomenon is known as gravitational lensing. Now imagine a signal, a beam of radio waves, traveling across thousands of light years. If that signal passes near a massive object, it can be bent, delayed, split, or redirected entirely away from us. Even if a civilization was aiming a message in our general direction, the cosmos itself could scatter that signal before it ever reaches us. But there's more. As signals travel through expanding space, they lose energy. Their wavelengths stretch out, a phenomenon called cosmic redshift. Over extreme distances, what began as a clear transmission might stretch so far that it slips beyond the range of our current instruments. And here's the strange part. We've never truly tested this ourselves. We've never sent a signal across thousands of light years and waited to see what comes back. All of our knowledge about how signals behave over galactic scales is based on models and assumptions, not direct evidence. It's an experiment still waiting to happen. And until we run it, we can't say for certain what we're missing or how many distorted whispers from the stars we've already overlooked. And if our models are even slightly off, we could be blind to entire categories of communication. Civilizations might be out there, shouting across the stars, but by the time their voices reach us, they've been warped into silence, not absent, just lost in translation. What if we're not just early? What if we're truly alone in our galaxy? Maybe intelligent life is far more rare than we imagined. The universe is vast, yes, but galaxies are separated by unimaginable distances, and the physics of communication may not stretch much beyond their borders. It's possible that the hard limit of interstellar communication is the galaxy itself, a kind of cosmic neighborhood where signals can still cross, if barely. Beyond that, the distances, distortions, and timescales become too extreme. Even light, the fastest thing we know, would take millions of years to reach the next galaxy. So if there's only one intelligent civilization per galaxy, or worse, if ours is the only one in the Milky Way, we wouldn't just be isolated. We'd be surrounded by silence with no one else to talk to for now, or perhaps ever. And maybe that's the rule, not the exception. Each galaxy could be a lonely island in a cosmic ocean, home to one thinking species at a time, separated not just by space, but by physics itself. If that's the case, then the universe isn't quiet because it's empty. It's quiet because every voice is stranded, each calling out from their own distant island, never meant to be heard by another. The Signal Degradation Hypothesis doesn't deny the existence of intelligent life. On the contrary, it assumes they may very well be out there, trying to communicate. But even if civilizations are transmitting across the stars, the universe itself might be scrambling the message. As signals travel over thousands of light years, they pass through regions of space filled with dust, plasma, radiation, and immense gravitational forces. These distortions don't just weaken a signal. They can stretch it, shift it, or scatter it beyond recognition. We might be listening, but what we're really hearing could be faint echoes, whispers buried beneath cosmic static, the residue of something once clear, now unrecognizable. It's like trying to tune into a foreign broadcast with a broken radio, overlaid with static and warped by wind and rain. In the end, the problem may not be absence. The signals might be everywhere, but we just haven't learned how to hear them. If the universe seems silent, maybe it's not because no one's talking. Maybe it's just speaking too softly, or through a storm of distortion we haven't yet learned to decode. The signals could be out there, faint, scattered, buried in noise. Until we know how to truly listen, we wait, we watch, and above all, we keep listening.